Welcome to MasterCode. Episode 3, and today we're going into the territory that separates someone who uses Linux from someone who truly understands it. And that difference matters more than you know. Here's the truth about Linux and hacking. You can install Kali, open Metasploit, and run exploits without really knowing Linux. But you'll hit a wall. A wall where you get a shell and don't know what to do with it. A wall where you find a SUID binary and don't understand why it matters. A wall where your script fails and you can't debug it. That wall is built from a lack of Linux fundamentals. Today we break through it. We're covering the file system layout, permissions, process management, networking commands, bash scripting, text processing, and privilege escalation methodology. Every single topic connects directly to your ability to operate effectively on a compromised system or in a CTF environment. We're also covering reverse shells, shell upgrades, and file transfer techniques that you need to know when you actually get access to a target machine. These aren't academic concepts. They're skills you will use in every CTF you touch, every hack-the-box machine you solve, and every real penetration test you perform. By the end of this episode, your relationship with the Linux command line will be fundamentally changed. Let's get after it. Before we get into commands and techniques, let me say something directly. The skills we're covering in this episode are extremely powerful and extremely dual use. Understanding privilege escalation paths, finding SUID binaries, reading system configuration files, these capabilities exist on every Linux system on Earth. That includes your company's servers, your university's systems, and critical infrastructure. You can practice every single technique we show today legally and ethically without ever touching a system you don't own. Your virtual machine lab is where you practice. Hack the Box provides thousands of retired machines with full walkthroughs. TryHackMe has guided learning paths specifically designed for this content. VulnHub has hundreds of downloadable vulnerable VMs. These platforms exist precisely because the security community recognized that people need a safe and legal place to practice. There is absolutely zero legitimate reason to practice these techniques on unauthorized systems. Zero. The professionals who build careers in penetration testing, who get hired by top firms, who work with Fortune 500 companies, they all built their skills on legal platforms and in home labs. That is the only path. If you find yourself thinking about testing these skills somewhere unauthorized, stop and set up a VM instead. We clear? Good. Now let's learn. Why is Linux the operating system for hackers and security professionals? It's not tradition or preference. It's the architecture. Let me walk you through the 6 core reasons. First, Linux is open source. Every component, the kernel, the utilities, the package manager, is publicly readable code. When you want to understand how a tool works at a deep level, you read the source. You can't do that with Windows or Mac OS. Second, the file system philosophy that everything is a file. Devices are files. Network connections can be represented as files. Processes expose their information through files in the proc virtual file system. This unified approach means you interact with system resources using the same tools you use for regular files. Third, the shell. The bash shell combined with standard Unix utilities is the most powerful interactive programming environment ever created for system administration and security work. Fourth, process control. You have fine-grained control over every running process. Priority, signals, resource limits, all configurable from the command line. Fifth, networking. The Linux networking stack is fully exposed through standard command line tools. You can craft packets, capture traffic, modify routing tables, and analyze network behavior without installing additional software. And sixth, the security tool ecosystem. Virtually every offensive and defensive security tool is written for Linux first. Python scripts, Ruby gems, Go binaries, they all assume a Linux environment. Running natively on your target platform is always better than emulating it. This is why Kali, the Linux file system layout, is not random. It follows the file system hierarchy standard, and once you understand the structure, every Linux system you ever access becomes immediately readable. Let me walk you through the directories that matter most for your work. The first directory every hacker checks is /etc. This is the configuration hub for the entire system. User accounts live in etc. password. Password hashes, if the system is old enough, live in etc. shadow. The sudoers file that controls who can run commands as root lives here. Host-based DNS mappings in etc. hosts. Cron job definitions in etc. cron tab. Anything that configures system behavior lives somewhere in etc. /var is your next stop. This directory holds variable data that changes over time. Application logs live in var log. Web application files often live in var www.html. Database files, mail spools, and package manager state files all live somewhere under var. The /proc directory is special. It's a virtual file system that the kernel creates in memory to expose information about running processes. Read proc version for the exact kernel version. Read proc net TCP for a list of open TCP connections with their socket state. This information is live and updates in real time. /home contains user home directories. Each user has their own directory where personal files, shell configuration, and crucially SSH keys and bash history files live. And /tmp is world writable and executable by default. During exploitation, this is often the only directory where you can write and execute. Navigation and file operations form the foundation of everything you do on a Linux system. You need these commands to be completely automatic, as natural as breathing, before you move on to more advanced techniques. pwd shows you where you are. ls with the -law flag shows you everything in the current directory, including hidden files, their permissions, their owners, and their sizes. The hidden files, the ones starting with a dot, are where configuration lives. The -law flag combination is what you always use. Just ls is not enough. The find command is one of your most powerful tools. Find followed by a starting path and search criteria searches the entire file system for what you need. Find / to search from root. Then specify conditions like name followed by the file name pattern, perm for permission-based searches, or type to filter for files versus directories. Always redirect errors to dev null with 2 greater than dev null, because searching from root generates permission denied errors for every directory you can't read. Locate is faster than find because it searches a pre-built index database rather than scanning the file system in real time. But it only knows about files that existed when the database was last updated. For current file locations, use find. The grep command finds patterns inside files. Grep followed by a pattern and a file name searches that file. The -r flag makes it recursive, so it searches an entire directory tree. This is how you search for password strings, configuration values, and specific content across an entire web application directory. These 3 commands, ls, find, and grep, handle 90% of your file system work. Linux file permissions are one of the most important security concepts in the entire operating system. Understanding them is not optional. It's foundational. Every file and directory has 3 sets of permissions, for the owner, for the group, and for everyone else. When you run ls with the law of flags, you see a 10-character permission string. The first character is the file type. A dash means it's a regular file. A D means it's a directory. An L means it's a symbolic link. The next 9 characters are 3 groups of 3. Each group represents read, write, and execute permissions for owner, group, and others respectively. If the character is present, the permission is granted. If it's a dash, the permission is denied. The dangerous permission to understand is SUID, the set user ID bit. When SUID is set on an executable file, that file runs with the permissions of its owner rather than the permissions of the user who runs it. If root owns a binary with SUID set, anyone who runs that binary is effectively running it as root. The find command with the perm-4000 flag finds all SUID binaries on the system. When you get access to a Linux machine, this is one of the first things you check. Visit gtfobins.github.io. This site lists every common Linux binary that can be used to escape to a root shell when SUID is set or when accessible via sudo. Vim, map, Python, find, all of them have documented privilege escalation paths. Find one of these with SUID set, and the escalation to root is typically a single command. Process management is a skill that pays dividends constantly in security work. Understanding what's running on a system, how to control processes, and how to use background execution effectively will make you dramatically more productive. The PSAUX command is your system snapshot. It shows every running process with the user that owns it, CPU and memory usage, and the full command line that started it. This is the first thing you run when you want to understand what a system is doing. When you're on a compromised machine, PSAUX shows you other users' processes, active services, and sometimes processes that have credentials embedded in their command line arguments. Top and Top provide real-time monitoring. Top is the better version with color coding and the ability to kill processes interactively. Install it on every system you configure. The kill command sends signals to processes by ID. The most important signals are sigterm, which asks the process to stop gracefully, and sigkill, which terminates the process immediately regardless of its current state. Kill all followed by a process name sends a signal to all processes with that name. For long-running scans, the nohup command is essential. Running nohup followed by any command means that command keeps running even if your terminal closes or your SSH session disconnects. Combine it with an ampersand to run it in the background. Output goes to a file called nohup.out by default. And cron tab, the cron job scheduler, is important both for your own automation and as a privilege escalation target. Run crontab-l to see your own scheduled jobs. Look at etc crontab and etc cron.d for system-wide scheduled tasks. Linux networking commands are the layer between you and your targets. You need these internalized before any active testing work. Let me walk through the essential toolkit. The IP address show command replaces the older ifconfig and shows all network interfaces with their IP addresses, MAC addresses, and states. You'll use this constantly to verify your network configuration, confirm your VPN is running, and identify which interface connects to your target network. IP route show displays your routing table. This tells you which interface handles traffic to which subnets and what your default gateway is. When traffic is taking an unexpected path, the routing table explains why. The SS command, which stands for socket statistics, replaces netstat and shows active network connections and listening ports. SS with the tulpan flag shows TCP and UDP listeners with the process ID that owns each port. This is critical when you want to know what services are running on a system. For connectivity testing, ping is basic but useful. Curl with the capital I flag fetches only HTTP headers without downloading the body. This gives you server type, framework version, and other information headers that help identify the technology stack. Netcat is your Swiss Army knife for network connections. NC with the NLVP flag starts a listener on a port waiting for incoming connections. NC followed by an IP and port makes an outgoing connection. This is the foundation of reverse shell communication. And Python 3 with the mhttp.server flag instantly creates an HTTP server serving files from the current directory. Use this to transfer tools and payloads to target machines. Bash scripting is where your Linux knowledge multiplies your capability. Instead of typing the same 20 commands every time you start a test, you write a script that does it automatically. Let me walk through the elements you need. Every bash script starts with a shebang line, #bang/bin/bash. This tells the system which interpreter to use. Variables store data using an equal sign with no spaces. $1, $2, and so on capture command line arguments when you run the script. This makes your scripts flexible and reusable across different targets. Conditionals use the if bracket syntax. Check if a file exists, if a tool found results, if a host responded to a ping, or if a command succeeded. The double ampersand runs the second command only if the first succeeded. The double pipe runs the second command only if the first failed. Loops are where automation really shines. The for loop combined with a list of targets, from a file or from command output, lets you run any tool against hundreds of targets automatically. Use a while loop to read targets line by line from a file with IFS set to prevent trailing whitespace issues. Command substitution, where you wrap a command in $parentheses, captures the output of that command into a variable. Then you can search it, test it, and use it as input to the next tool in your pipeline. And error handling prevents your scripts from silently failing. Redirect errors to a log file, use exit codes to detect failures, and add status messages so you know what the script is doing when it runs unattended. Let me show you a real, working recon script that you can use immediately. This is the type of automation that makes your workflow significantly more efficient. The script takes a target IP or hostname as its first argument, stored in the target variable. It creates a dedicated output directory for that target under a recon folder. This keeps all your results organized by target automatically. Then it runs nmap with the SV and SC flags for service version detection and default scripts, saving output to a text file in the target's directory. After nmap completes, it runs gobuster for web directory enumeration against the standard HTTP port. The output goes to a separate file in the same directory. At the end, everything is neatly organized. This script is the skeleton. You extend it based on what your tests need. Add a Nikto web scan for detected web servers. Add a searchsploit lookup for discovered service versions. Add a wpscan call if WordPress is detected. Add subdomain enumeration for external targets. The power of scripting is that once you've built and refined this once, every future engagement starts with one command instead of 20. You also get consistent output formats that you can review later without remembering what flags you used. And you can share it with your team. Everyone runs the same baseline recon and produces comparable outputs. Start with this simple script. Customize it as your methodology evolves. It will become one of your most valuable tools. Text processing is the glue that connects all your tools together. Each tool produces output and you need to extract, transform, and pass that output to the next tool in your workflow. Master these 4 utilities and your productivity will increase dramatically. Grep is probably the most used command in security work after ls and cd. Its core function is filtering. Given a stream of text, it shows only the lines that match your pattern. In practice, you pipe tool output into grep to extract specific information. Nmap output piped into grep followed by the word open shows only open ports. The grep-r flag searches recursively through directory trees, which you use to hunt for configuration files containing passwords or interesting data. The grep-i flag makes matching case insensitive, important when searching for things like password in various capitalizations. awk handles structured text extraction. Think of it as a column picker. When map output has a consistent column format, awk with a print $number statement extracts specific columns. It handles custom field delimiters with the capital F flag. Use it to parse the delimited fields in etc. password. Sed is your find and replace tool for streams of text. The substitution command replaces patterns inline and works on STIN through pipes. Essential for converting tool output formats and cleaning up data before passing it to another tool. And sort combined with unique handles deduplication. When you're collecting subdomains from multiple sources, sort them together and pipe through unique to get a clean deduplicated list. The sort-u flag does both operations simultaneously. Pipes and redirection are what transform individual commands into workflows. Understanding them deeply unlocks the full power of the Linux command line. The pipe character, that vertical bar symbol, connects commands in a chain where the output of each command becomes the input of the next. You've seen this already with grep. Cat file pipe grep pattern. But the pipe chain can be as long as you need. You might do map output pipe grep open pipe awk to extract port numbers pipe sort to order them pipe unique to deduplicate. That's 4 commands doing specialized work in sequence. Each one is a focused tool doing one thing well. Redirection is for saving and controlling where output goes. The greater than sign sends command output to a file, creating the file if it doesn't exist and overwriting it if it does. 2 greater than signs appends to an existing file rather than overwriting. This is essential when you're running multiple scans and collecting all results into one report file. The 2 greater than dev null redirect is the one you'll use constantly. The number 2 represents standard error, the stream where error messages go. Redirecting it to dev null, which is a device that discards everything written to it, silences error messages. When you run find from root, you get hundreds of permission denied errors. Adding 2 greater than dev null removes all of them and shows only actual results. And 2 greater than and 1 redirects both standard output and standard error to the same place. Use this when you want to save everything including errors to a log file for later review. User management knowledge serves 2 purposes in security work. First, you need it to manage your own systems and lab environments. Second, and more directly relevant to hacking, it's one of the first things you investigate after gaining access to a system. The ID command tells you exactly who you are on a system, including your user ID and all group memberships. Groups are critically important. The disk group gives you access to raw disk devices. The sudo group gives you sudo capability. The Docker group effectively gives you root access through container mounts. Knowing your group memberships immediately tells you what paths to privilege escalation might be available. The whoami command is simpler but essential as a quick check. W shows you all currently logged in users, what they're running, and their idle time. This tells you if an administrator is actively working on the system, which matters for stealth considerations during authorized tests. The last command shows login history pulled from system logs. It tells you who has logged in, from where, and when. Useful for understanding user patterns. Now for the privilege escalation relevant commands, sudo-l shows what you can run with elevated privileges. This is always the first check. If you can sudo any standard binary listed on GTFOBins, you can escalate to root immediately. The crontab files at etc. crontab and the etc. cron directories contain scheduled tasks. If a cron job runs as root and the script it calls is writable by your user, you can modify that script to add your own commands that will execute as root the next time the cron job runs. These misconfigurations are incredibly common in CTF machines and exist in real environments too. SSH, Secure Shell, is the primary tool for remote access in Linux environments and it has capabilities far beyond simple terminal connections. Let me walk through the features that matter for security work. Basic SSH connection is straightforward. SSH followed by user at host name. Add the P flag and a port number for non-standard SSH ports, which is very common in CTF environments. SSH key authentication eliminates password prompts and is significantly more secure than password authentication. Generate a key pair with SSH keygen. The private key stays on your machine. Copy the public key to the target with SSH copy ID. From then on you connect without entering a password. Port forwarding is where SSH becomes a pivoting tool. The capital L flag creates local port forwarding. You specify a local port, the destination address as seen from the SSH server, and the destination port. Traffic to your local port gets forwarded through the SSH tunnel to the destination. This lets you access services that are only reachable from the SSH server, making it essential for internal network access during engagements. The capital D flag creates a dynamic SOCKS proxy. Specify a local port and SSH creates a SOCKS 5 proxy through that connection. Configure your proxy chains to use that proxy and all your tool's traffic routes through the compromised machine. This is one of the most powerful pivoting techniques available. The capital R flag creates reverse port forwarding, where the remote machine opens a port that connects back to a service on your machine. Use this to expose services behind NAT or firewalls. And the SSH config file at .ssh/config lets you define named connection profile. Linux privilege escalation is a discipline in itself. Let me give you the methodology that experienced penetration testers actually follow. The foundation is enumeration. Never guess. Never try random exploits. Enumerate systematically first because the answer is almost always in the configuration rather than a kernel exploit. Start with automated enumeration. LinPEAS, which we'll cover on the next slide, runs in seconds and checks hundreds of potential privilege escalation paths automatically. If you can't run LinPEAS, do the manual checks in this order. First, check sudo permissions with sudo-l. This single command has ended countless CTF machines immediately. If you can sudo any binary without a password, check GTFOBins for the escalation path. Second, find SUID binaries using the find command with the perm-4000 flag. Cross-reference every result against GTFOBins. Third, inspect cron jobs. Read etc. cron tab. Look in etc. cron.d and etc. cron.daily and similar directories. Check if any cron job runs a script that you can write to. If root runs a script every minute and you own that script, you own root. Fourth, look for interesting files. Check home directories for .bash history files which sometimes contain commands with embedded passwords. Look for config files in web roots that contain database credentials. Search for private SSH keys. These are found with find, type f, name ID_RSA. And fifth as a last resort, kernel exploits. Match the exact kernel version from unnamed-a against known exploits in search. LinPEAS, the Linux Privilege Escalation Awesome Script, is the most comprehensive automated privilege escalation enumeration tool available. You should run it on every Linux machine you get initial access to during CTF competitions and authorized penetration tests. Here's how to use it effectively. On your attack machine, download the latest LinPEAS from its GitHub releases page. Then serve it over HTTP using the Python HTTP server. This is the fastest transfer method when you have a web server available. On the victim machine, use curl pipe directly to sh to download and execute LinPEAS in a single command. This avoids writing the script to disk, which is useful for operational security in real engagements. If you prefer to save the script first, curl or get it to the target, chmod it executable, then run it. LinPEAS uses color coding to communicate severity. Red and yellow together indicates a finding with approximately a 95% chance of leading to privilege escalation. Take these extremely seriously. Red alone means high priority. Yellow alone means worth investigating. All other findings are informational. The script checks sudo permissions, SUID binaries, writable directories, cron jobs, running processes, network interfaces, installed software versions, path variable issues, capabilities, and dozens of other potential vectors. The output is long. Pipe it through less for comfortable reading or redirect to a file for reference. Focus on the colored sections first. When you find a red finding, cross-reference it on GTFOBins, hack tricks, or search for the specific vulnerability to find the escalation path. LinPEAS finds getting files onto and off of compromised systems is a constant challenge in real engagements and CTF machines. You need multiple techniques because firewalls, outbound filtering, and missing tools will block your first choice regularly. The Python HTTP server is the fastest and most reliable method when it works. One command on your attack machine creates an HTTP server serving any directory. Then get or curl on the target pulls files down. This works through most firewalls because outbound HTTP on port 8080 is rarely blocked. If standard ports are filtered, try running your HTTP server on port 80 or 443, which are almost never outbound blocked. Netcat file transfer works when HTTP doesn't. On the receiving end, start a netcat listener redirecting to a file name. On the sending end, pipe the file into netcat connecting to the receiver. It's raw and unencrypted but extremely reliable. Works on any system that has netcat installed, which is nearly every Linux system. SCP, Secure Copy, is the cleanest option when you have SSH credentials. It uses SSH infrastructure so it's encrypted and logged just like SSH connections. Copy from local to remote or remote to local with the same syntax. For truly restricted environments where no outbound connections are possible, base64 encoding lets you transfer files as text. Base64 encode the file on one end, copy the text output manually through any text channel, paste it on the other end, and base64 decode. This even works through web shells where you're limited to HTTP requests. Always have at least 3 transfer methods ready before starting any engagement. Understanding shell types is essential for both getting access and maintaining it during penetration tests. The 3 types you need to know are reverse shells, bind shells, and web shells. A reverse shell makes the target machine initiate the connection back to your attack machine. You start a listener on your machine waiting for the incoming connection. Then you deliver a payload to the target that executes and connects back. The primary advantage is that it bypasses inbound firewall rules on the target because the connection is initiated outbound, and most firewalls allow outbound connections by default. This is the most common shell type in CTF machines and real engagements. A bind shell works the other way. The target opens a port and listens for your incoming connection. You then connect to that port and get a shell. The problem is that the target's firewall often blocks inbound connections on arbitrary ports, which kills this approach. Bind shells are mainly useful when you're behind NAT and can't receive incoming connections yourself. Web shells are scripts uploaded to a web server that execute commands through HTTP requests. PHP web shells are the most common. You upload the shell through a file upload vulnerability, then access it via your browser or curl, and send commands as URL parameters or post data. Web shells are persistent because they survive system reboots and don't require a continuous connection. But they're noisy, easy to find in file audits, and typically limited to the web server user's permissions. In practice, you upgrade web shell access to a proper reverse shell as quickly as possible for better interactivity and capability. Getting a reverse shell is exciting. Watching your netcat listener catch an incoming connection is a great feeling. But what you actually get is a limited, fragile shell that breaks constantly. You can't use tab completion. Ctrl+C kills your connection instead of the current process. You have no command history. Certain interactive programs refuse to run. You need to upgrade immediately. The Python PTY method is the standard approach and works on almost every Linux system. First, run the Python 3 spawn command to allocate a proper sudo terminal inside your shell. Immediately your shell looks more normal. Next, background the shell with Ctrl+Z to temporarily suspend it and return to your local terminal. Then run stty raw with the echo flag, which puts your local terminal into raw mode and disables local echo. Then fg brings the shell back to the foreground. Finally set the term environment variable to stRM 256 color so the remote shell knows your terminal capabilities. After this process you have full arrow key history, tab completion, Ctrl+C works correctly, and interactive programs like Vim and top function properly. The rowrap alternative is simpler. Install rowrap on your attack machine and prepend it to your netcat listener command. Rowrap handles readline functionality on the local side, giving you command history and arrow keys without the stty dance. It's not as complete as the Python PTY method, but it's faster to set up. SOCAT offers the most complete solution with a full TTY from the start, but it requires SOCAT to be available on the target system. When in doubt, use the Python PTY method. It works everywhere. Beyond the core commands we've covered, there's a set of utility tools that professional hackers use constantly and that you should add to every system you configure. Tmux is the most impactful. It's a terminal multiplexer that gives you multiple windows and panes in one terminal session. More importantly, Tmux sessions survive SSH disconnections. When your connection drops during a long scan, you reconnect to the same SSH session, reattach your Tmux session, and everything is still running exactly where you left it. Create a Tmux session with Tmux new, name it something descriptive, and always work inside Tmux on remote systems. Text editors are non-negotiable skills. Nano is approachable for beginners. Open file, make edits, Ctrl+X to exit. Vim is more powerful and faster once learned, with a modal editing system that keeps your hands on the home row. The key thing is you must be able to edit files on remote systems that only have command line access. Learn at least Nano to a functional level. The JQ tool parses JSON from the command line. As modern APIs and web applications increasingly use JSON responses, JQ becomes essential for testing. Pipe API responses through JQ with a dot to pretty print them. Use JQ field selectors to extract specific values from nested JSON structures. XXD shows files in hexadecimal format. When you find a binary file or a suspicious file with an unknown format, XXD lets you read its raw contents. Check the magic bytes at the start of the file to identify its true type regardless of its extension. And strace traces system calls made by a running process. When you want to understand what a binary does without reading its source code, strace shows you. You're not going to master Linux by watching one video. This is a skill that builds over years through constant hands-on practice. But the good news is that the resources available to you are exceptional. Let me point you to the ones that actually matter. The man pages are your first resource and they're already installed on every Linux system you'll ever use. Man followed by any command name opens the full manual for that command. The man pages are comprehensive, accurate, and always available offline. Read the man page for nmap. Read the man page for bash. Read them even for commands you think you know. You'll find options you didn't know existed. Over-the-wire bandit is mandatory. It's a series of 34 Linux challenges that start from absolute zero. Each level introduces new concepts and builds on the previous ones. This is the single best hands-on Linux training resource for beginners and it's completely free. Go do all 34 levels. TryHackMe has structured learning paths specifically for Linux security. The Linux Fundamentals path is guided and interactive with an in-browser terminal. Great if you prefer guided instruction over pure challenge-based learning. Hacktricks is the most comprehensive offensive security reference on the internet. The Linux privilege escalation section alone covers dozens of techniques with example commands. Bookmark it and check it whenever you hit a dead end. GTFOBins is your privilege escalation lookup tool. When you find an interesting SUID binary or sudo permission, GTFOBins tells you instantly if there's a known escalation path and gives you the exact command. And linuxjourney.com covers Linux from first principles in a gamified format. All of these resources are free. You now have a real foundation in Linux. File system navigation, permissions and SUID exploitation, process management, networking commands, bash scripting, text processing, pipe and redirect mastery, user enumeration, SSH tunneling, shell types, shell upgrades, file transfers, privilege escalation methodology, and LinPEAS. That's a lot. And all of it is directly applicable right now. Here's your action item: open over-the-wire Bandit and start level 0. Don't skip it because it feels too basic. The early levels build the muscle memory that makes later levels possible. The later levels will absolutely challenge you. Work through all 34. When you're done, you'll be genuinely comfortable with the Linux command line in a way that most beginners never achieve. Episode 4 is coming next, and we're going into Python for security. We're going to build actual offensive tools from scratch: port scanners, web crawlers, exploit frameworks, password crackers. Python is the language of security research, and we're going to use it to its full potential. Subscribe so you catch it the moment it drops. If this episode gave you something valuable, a like takes 2 seconds and genuinely helps this channel reach more people who are serious about learning security. See you in episode 4.